Hello Algebra 1 students, we are in Unit 3, Tier 2, Lesson 2b, Transforming Linear Functions Horizontally from an Equation. So let's check off our booklet. Here we are in Lesson 2b, Transforming Linear Functions Horizontal from an Equation in Tier 2. With horizontal translations, the shift is always inside of mathematical bounding symbols. So what I mean by that is like it's always inside a parenthesis or inside an absolute value bar, or with quadratics it'll be inside of parentheses with a square up here, or with cubics it'll be inside of parentheses with a 3 to the power of 3. So a horizontal is always inside mathematical bounding symbols, and it's in there with the x variable. So like in an absolute value you would see something like this. In addition, the shift is always opposite of what you would think. So with this example right here that I did for you of x minus 2 inside of an absolute value, you would think you would go left to or back to on the number line because that's where the negative values are. But in actuality, what happens is it's opposite of what you would think. So you would go right to with that horizontal shift in that absolute value. So let's take a look at these lines over here. Well, here's our parent function again that goes through the origin, and its equation is f of x equals x. And then if we look at this blue shift here, we notice that it shifts 1, 2, 3 units to the right. So if we wanted to write this as a horizontal translation, we would write f of x equals, open parentheses, x minus 3, because it's opposite of what we think. And then if we looked at this green translation right here, and we wanted to write the equation for it, it would be f of x equals, and then we go 1, 2, 3, 4 back. So going 4 back, we would think minus, but because it's opposite of what we think, inside of the parenthesis, we would put x plus 4. And those are the equations that go with these corresponding lines on the Cartesian plane. Obviously, like I said in the previous lesson, this is hard to see when the linear functions have a slope of 1, but it'll be more noticeable when we do absolute value functions and way more noticeable when we do quadratic functions. Good luck on your problem sets.